Hi all, my name is Pranjul Sharma and today I'll be talking about Redux Thunk, generators and Redux Saga. So before getting into our topic of discussion, let's see some news that I have written down for us. Dell Technology retains the top spot in India's external storage industry in Q3 2019. Dell Technologies has maintained its leadership in India's enterprise storage system industry with 32% by vendor revenue. The company is nearly 2.6 times the share of its nearest competitor in Q3 2019. Also, Citrix has launches next generation performance analytics service for apps and desktops. Citrix Analytics for Performance, a next generation service that goes beyond analyzing your system infrastructure and can help IT administrator to also analyze for the user experience for our application that the user is having. Gartner's raised global IT spending to reach $3.9 trillion in 2020. It is an increase of 3.4% by 2019 and it is expected to go up to $4 trillion by next year. Stencil, it is a compiler that is made by Ionic team that is used to generate web components. It takes popular features such as Virtual DOM, TypeScript and JSX to create standard web-based components that can be used with any of the other frameworks or libraries like Angular, React and Vue. So now let's go into our topics. First we'll cover what is Redux and then we'll see why we need Redux Thunk and Saga, and we'll see the working of generators. So Redux is a state container for a JS application. It helps you manage your application state. A state can be thought of as a data that is being shown in an application at a particular point in time. To manage that data efficiently, we have Redux library. So it has three principal concepts. Store, it is a single state tree object containing your app state. It is a single source of truth so that whenever you need your app state, you can directly refer to store. Also, it is easier for us to manage this state for serializing if we want to store, if we want to persist our state. Since it is a single object, we can just directly JSON or stringify it and then parse it later and provide it as an initial state for our store. Now we have our store, we need to modify it. So for that we have actions. So actions are our only way through which we can modify our app state. It returns a plain JS object which is then dispatched by the Redux and the reducer updates the states accordingly. So reducer, these are the pure function which takes initial state and the action. Whenever there is an action dispatched from the action creator, it takes that action and perform the data manipulation and store it in store. But the thing is that reducer maintains immutability so that Redux can detect for changes and send the update to the components that are listening for particular store variables. Now this flow you can see as in the diagram. View calls the action creator, it dispatches action in form of plain JS object, then it goes to reducer, reducer modifies the state, copies the previous state and then updates the new changes to it and then returns it. So it is a new state each time it returns and then it goes to store, then store sends the new state to the views. Now the thing is this flow is synchronous. Let's say if we want to have a set timeout or we want to have a network call in between then dispatch. So we cannot directly do it in our action creator because action creator does not wait, and if we return a plain JS object at the end of it, though it will be dispatched to reducer, otherwise null will be dispatched to reducer. So for making this flow asynchronous so that we can make network requests in between, we use our middlewares. So a very basic middleware is a Thunk middleware. It is a simple function which allows you to return a function instead of a plain JS object from our action creators. The function which we will be returning from action creators have the following pattern or API structure. It takes dispatch, getState and extra argument as its parameters. Dispatch is used to dispatch the action to the store. GetState is used to get the state of our application and extra argument is used when we are configuring it. It is rarely the case we use it. The function returned by action creator handles the async part, mainly manages the network request and dispatches action accordingly. So now you can see that the action now returns a function which is then executed by middleware and then middleware forwards the action to the reducer and update the store accordingly. So we will see Redux Thunk in action. if you go into normal store, your action will be returning a plain JS object. But if we want some network calls, we can do that from this as well using Redux Thunk. So first see how we set up Redux Thunk in our application. We just need to import this Redux Thunk library and then use Thunk function from that library and use apply middle that is provided by Redux. Now this Thunk, it is a function that returned a function which takes next as a parameter. That in turn returns a function that takes action as a parameter. So whenever there is an action creator dispatches a function or action, it goes to this middleware, it checks whether it is a function or a plain JS object. If it is a function, then it maps, then it calls the action with the dispatch and get state from the store. If it is just an object, then it dispatches it using a next keyword that is passed to the outer function. So now if we want to make our network request, now we can return a function from a action creator. Now if you want to show a loading indicator, that we can use the dispatch action. Now this makes the network call, and when this resolves, it dispatches an action to our store. If the network API fails, then it goes to the error block. You can see for the mocking purposes, I have returned a promise from this function that resolves after 1 second. So it is fairly simple to use. But let's say if you are having an application in which you want to just take the first request or the last request if user clicks multiple times, in this case the all requests will be processed. If you want to do that, you need to apply our functionality in which you will be looking for previous pending request and then cancelling it for on your own. But you can use another API, another library called Redux Saga that help you manage the things according easily and manage it on your behalf. So before getting into Saga, we'll see what is generators, the basic working, the basic concept on which Saga is based. So generators. Generators are a special kind of function that is introduced in ES6. Using these functions, we can pause the function from the inside and resume the function from the outside. So we do not need to maintain global variables to check whether the function was let's say if you are making network requests multiple times and we are looking that it is the third request or the fourth request, we need to maintain a global variable that every time the function is called, we need to increment the counter. But using generators, we do not need to maintain any global variables. What we can do, we can just simply pause the function on the inside and we can just maintain it in a local variable and check whether it has been called multiple times or not. So when we call a generator function, it returns an iterator object using which we start the execution of the function or resume it in between. Yield keyword is used to pause the function from the inside, and if we want to supply some value to the caller function, then we can pass it through yield. It returns a value in form of an object that the value is mapped to the value key, and there is also one other key called done that specifies that the generator function working has been finished or not. This iterated or next method is used to resume the function if it has been paused, and if you want to pass some value to the generator function, then we can use it here, the optional value we can pass it. Also we can cancel the generator function in between if you want to using iterator's return method. This is the main concept why Redux Saga prefers generator over async await, because async await, it depends on promises and promises cannot be cancelled, but generator functions, they can be cancelled using this return keyword. So now let's see an example of generator function, how it works. So to specify that it is a generator function, we use a star keyword either at the end of the function or at the start of the function name. It is preferred to put it here so that we can distinguish between these functions. Now this is a simple function which returns some value, which pauses 3 times. First it returns a object, another time it returns a simple value, and another simple value, and generator finishes. So if you see that I console log it, and when I call the function, it does not immediately get executed, it just returns an iterator object, and whenever we make the first next call, it starts the execution of the generator function. That's why this line gets printed first and then this one, because now when the command comes here, it calls the iterator's next method, which starts the generator function's execution. So command goes here, generator function begins, it takes the value that yield, okay, yield keyword first sends the value to the outer function, then on the next call, it receives the value from the outer function. So on this call, it then sends the value to the outer function in the form of an object with value and done, then to specify whether the generator function working has been finished or not, and the value as an object which shows you that A is 1 here. Now when the next time we make a next call, this value then goes to here, because the function was paused here, it is then assigned to A, and then generator function prints the value A as B. Now the command goes here, it yields another value, so it pauses here, sends the value to the outer function and wait for the next call. Similarly, when this next call happens, the function execution command continues here and end. Similarly, at the very end, when there is no next yield operation or the function body has been finished, if we are returning a value, then the value will be here and done as true. Otherwise, the value will be undefined and done as true. If we make next call, because the generator function has been finished already, it will just tell you value finished, value undefined and done true. Now to show the cancellation property, just after two next call I have returned this value, I have returned the generator function. So what it does, it yields the first value, yields the second value, and on third iteration it finishes itself. So on the consecutive iterations it will show you that the working has been finished. So now we have seen how generator function works. We will see the Redux Saga. So Redux Saga is a library that aims to make application side effects easier to manage, easy to test, and for better error handling. For error handling, we just have try catch block, and then we can handle that error easily. So you can, when you see into official documentation, you will see the links what is Saga pattern. Then you will see there that Saga is a concept where a task is divided into subtasks, and each subtasks run parallelly. And if we are performing a transaction, if any of the tasks fails, we compensate for the other task, and then it finishes its execution. So you can consider it as a separate thread in an application that is solely responsible for side effects, means asynchronous programming, handling network requests and all. It provides a wide list of Saga helper which we can use to write complex logic easily. Sagas are divided into two things. Actually not divided, the pattern is divided into two things. One is watcher saga, one is worker saga. So watcher saga listens for a specific pattern to be occur from action creators, and then it calls the corresponding worker saga on that. So this take every, take latest, we use these effects in watcher saga, and other take, call, put, select, cancel, that we use in worker saga. So what is take every and take latest? Take every is used to look for every pattern, look for each of the pattern that is matching in the request and call the worker saga for that. Take latest, on the other hand, if there is a pending task on a particular pattern, it cancels that and calls the latest one only. So it keeps the one thread running only. Take is used in the worker saga to pause its functionality and look for a specific pattern. Call we can use to call a function with some argument in it. We can also use CBS if we want to pass a reference of this to the function that is being called. Put is used to dispatch an action. Select is used to get the store state, and cancel we can use it to cancel any pending effect. Now the thing is, Saga middleware handles all the function calling on behalf of us, so we do not directly call the functions. We delegate our task to Saga and middleware, and it calls the function on behalf of us. So as you can see, instead of handling the function itself, it listens for a specific pattern. Now our action creator returns a plain JS object as it was running previously, and whenever there is a matching pattern in the middleware's listeners, it then calls the worker saga on that, which in turn dispatches action to the reducer. Now the thing is, because of generator functions, it makes our code look like more synchronous and hides away the asynchronicity of the application, and the other flow remains same. Our action creator becomes pure again. We'll see that in action. For first, to initialize and basic setup for our Saga, what we do, we import this library, call this function, returns an object which we apply here in the apply middleware and run our root Saga. Root Saga is nothing but like a root reducer that we supply while creating our store. So root Saga, it spawns multiple sagas. In this case we are having a single saga. If we are having multiple sagas, then we can supply it here. It returns a generator object which is then run by the Saga middleware. The next and return call we saw, Saga middleware handles it for us, so we do not need to write that part. Here, this is a watcher Saga, which look for this pattern and call this worker Saga on each request. If we are using take latest here, so it will call only for a latest request and cancel the pending tasks. And if we want to take the first task, then we can use take leading over here. Now, this call, it makes the call to this method with this data, and the result is given here. So we can use it with promises. The promises result will come here, and if we reject a promise, the error will come here. Similarly, once we get the result, so we use just put to dispatch an action to our store. Now we can see that this code looks much more readable and easier to use. Also, if we are using, let's say we are making another API call on the basis of this result, then we can use it simply on the next line. But if we are using Thunk, then we will have to use promise chaining and all. So this is a very basic Saga example. Also, you can see now our action creators becomes pure again. It only returns a plain JS object. So now let's look into some advanced concepts and the advantage of Saga over Thunk. So first, see what is non-blocking calls. We used call effect in our previous example. Call effect is a blocking call, which means it suspends the generator function until the call is resolved. But if we want to just continue the generator function functionality, then we can use fork effect in place of call effect. Also, take latest, it uses take and fork effect to spawn the worker Saga. Take every also, it uses take and fork effect to run multiple sagas. Running task in parallel, as we saw in root Saga pattern, we used all keywords to run our multiple sagas in parallel. This is like promise.all. The all promises runs in parallel. Similarly here, the task runs in parallel. Starting a race between multiple effects. Let's say if you want to have a condition, or if you are creating a game with a set time, with a timeout, like either the user scored within the time frame or the game's over depending upon some conditions, lives run out, something like this. So in that case, you can manage it easily with the race keyword. Here you will be having multiple effects as an object, and each effect will be mapped to a key, obviously, and then using that key we can check whether which effect won the race. Also, we can use the cancel keyword to cancel a task. There is also an effect called cancelled. If we call that function within our generator function, then it can tell whether the generator function functionality has been cancelled or not. Also, Saga is not limited to Redux. We can connect it to other Saga or external source, or we can, let's say if you want to queue actions and process one by one, then we can use that too using channels. Now let's see some advantage over Thunk. It gives us more synchronous looking code, easier to test, very little to less mocking, because now if you are to using Thunk, then we need to provide the mock data for our APIs. But in case of Saga, we just use call effect to create the similar effect, and then we can compare it between those two effects. Sagas are also composable, so it can wait for another Saga to finish its working. For that, we use a yield star keyword. It provides a list of helper functions that we can use it for writing complex logic easily. Some of these are throttle, debounce. Throttle is used to send a request in a particular time frame, single request only. Debounce is used to check whether the user has finished some action and waits for some time, then only send a single request. Race we have already saw. Fork is used to create a attached task to its parent, means parent will continue its functionality onto next task, but it will wait until all the fork task has been finished or not. Spawn, on the other hand, it is a detached subtask, So parent will not wait for the spawn task to finish, it will just finish immediately as soon as it reaches its ends, and that's it. So here are some useful links where you can go through how Thunk works, generators, Saga documentation, and example code repo. Thank you.